Grade 10s, and welcome to another video on the cosine graph. We're going to look at how to draw the original cosine graph, and then how do we adapt it and shift it and stretch it and move it up and down. All right, so let's look at the following two questions given, and then I'm going to quickly draw them. So it says, draw the following two graphs on the same set of axes for x as an element from 0 to 360. So when you put it into your calculator, you want to go to your table method, so your mode setup, and 3 for table. If you've got the older calculator, if you've got the newer one, you will press 7 for table, and then it gives you f of x. F of x is equal to cos alpha x closed bracket, and then you press equal. G of x, I like to just put 1 in. If you want to do 2, you can, as long as you just don't get confused with the coordinates given. If you don't want to put two graphs into one, you just press equal again. Then, very important, this is your this is your start and this is your end. So when you put it into your calculator, you'll start at 0, end at 360, and then you will see the steps. If you look here, you can put it into 45 degrees or you can put it into 30. It's best to put the tangent graph that we're going to do next into steps of 30. So if you always just want to stick with 30, you can, or otherwise you'll have to work with what has been given to you. Okay, so I'm going to put it into steps of 45, and then you press equal, and then it gives you the x and the y the coordinates, the x and the y intercepts. Okay, so I'm going to quickly draw cos x and 3 cos x. All right, and there's your cos x. So your y-intercepts I decided, or your y steps I decided to make it into steps of 1. And then very important, sorry, it should go nicely there through the 0. So very important, you have to label your two x-intercepts as well as your turning point. All right, so please take note of that everything is labeled, and then that you name the graph. And I always say to my students, use different colors, use highlighters. If you're scared, start with a pencil to draw it, and afterwards highlight it. When you're certain this is correct, you highlight your graph with whichever color you want to. Okay, so that is cos x. That is our original cookie cutter cos x graph, starting at 1, going to a minimum value of -1, and then going up again to 361 there as a coordinate. All right, so that is your cookie cutter mold. So let's see if we go and apply a vertical stretch. So what that means is it's a vertical stretch with a factor of, how did I get from 1 to 3? I times it with 3. Okay, so in red, I'm quickly going to draw 3 cos x. All right, so there you've got it. I've plotted it using my table method in my calculator. And then very important to label your turning point over there. Those 2 points I've already labeled, and I have copied the equation, the name of the equation there, g of x. All right, best to do it in different colors, then you can see very nicely what's happening. All right, so there's it. So it's your cos graph should look like a bowl that you are eating from. So those fancy bowls with a little bit of the edges on the side. Okay, so let's quickly have a look what types of questions we can ask you. So what is the period of f of x and g of x? So the same as the sine graph, it will always be 360 degrees. Okay, so the period again is how many degrees does a graph run through before it starts repeating itself. Okay, sorry, what I've drawn there was the sine graph, so the cos graph. So there's one full a wave, and then it goes again. So that up to there will be 360 degrees. Okay, so just note that for the sine and the cosine, it's always 360 degrees. Then write down the amplitude of f of x and g of x. All right, so for f of x, the amplitude is 1. If you look at your equation, there's a 1 there in front. And for g of x, it is 3. All right, remember amplitude is always a positive number. So for f of x, it's 1, and for g of x, it's 3. What is the maximum and the minimum values as a coordinate? So very important. Sometimes they ask you to write it as a coordinate of f of x. So f of x is the blue graph. Let's answer it in blue. What is the maximum value? The maximum value there is 0, 1, although that the cosine has 2 maximum values. So can you see the tippy top is over there and over there? All right, so let's have a look. Let's just ask the minimum value. The minimum value as a coordinate would be there, 180, negative 1. And then we can write the maximum as well. It will be 0, 1, and 361. Okay, then the maximum and the minimum values as a coordinate of g of x. So for g of x, can you see there's your minimum value and your maximum are these two sitting right on top. So it will be either maximum 0, 3 and 363, and your minimum would be 180, negative 3. Okay, what is the range of f of x and what is the range of g of x? So the range, I always say, if you had to put a little ping pong ball in between here, between which two values will it jump up and down from the minimum to the maximum? So over here it ranges from negative 3 all the way to 3, and for f of x it ranges between negative 1 and 1. So if I had to write it, you would say y is an element of negative 1 to 1, always minimum to maximum. And for here, g of x is y is an element of negative 3 to 3. And we put square brackets because it is included. Okay, now it says, describe the transformation of f of x, what it would have to undergo to become g of x. So what happened? It had a vertical stretch of 3, of a factor of 3. So if you look at f of x, the original was cos x, and then g of x was 3 cos x. So the only thing that happened, can you see that the amplitude changed from 1 to 3? So it was a vertical stretch with a factor of 3. Okay, now for which values of x is f of x equal to x? So for which values of x? So where is the two graphs exactly the same value? So let's have a look. Over there, can you see that? That's where they touch each other. That's where they equal to each other, as well as over there. So at x is 90 and x is 270. Okay, now they ask you for which values of x. So very important, for which values of x is f of x increasing? So f of x is the blue graph. Where is it increasing? So can you see it's going to go down, 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 down. Then at this point, it's going to stop. And then it's going to increase, increase, increase. So it's this part over here. But because they ask me for which values of x, I have to read it from the x-axis. So it's from 180, all the way to 270. So this part over here is where it is increasing. Okay, 180 to 360. So x is an element of 180 to 360. We are not going to include it. Why not? Because we're going to have round brackets, because at that point it stops, it stands still. Then it changes direction. It goes up, 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 and then it stops again. Okay, so that's why we cannot include those two parts. All right, last one where it says where g of x is decreasing. So g of x is the red graph. Let's do this. Where's g of x decreasing? So can you see from left to right, it's going to go down, 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 stop. And then it's going to start going up, up, up. So for which values of x? From 0 all the way up to 180. So this part over here. And at that part, it starts, so it's not in motion yet, and then it goes wee down, and then it stops, and then it starts climbing. So from 0 to 180, and we're not going to include 0 or 180. So x is an element of 0 to 180, round brackets. Okay. Good. Let's look at another one where it says draw the following two graphs onto one set of axes for x is an element of 0 to 360. So this is my starting point that I have to draw up to my end point, which is 360. Okay, so very important. These graphs carry on and on and on and on the x-axis both ways, positive and negative. But they're asking you to just draw a little snippet of that graph, which is from 0 to 360. Okay, although this one's labeled, sometimes they ask you just to draw from 0 to 180 or 0 to 270. So you have to adhere to that, and you cannot draw bigger than that. So it's only that snippet that has to be included in your on your Cartesian plane. All right, so I'm going to quickly draw these two graphs. You just punch it into your calculator, and you're going to see what it gives you. Okay, so I'm just going to quickly draw that. All right, so there's your cos x. Can you see it's been reflected upon the x-axis? So if I just had to quickly draw the original cos, it would look something like that. So can you see it's been reflected upon the x-axis, which will give you, let me just quickly erase that again, which will give you that negative cos x. And then the green one is your cos x minus 1. So it's the original again, shifted down, all with 1 unit. Okay, if you just have to see it like that, what's happening? All right, so let's have a look at the questions. Let's get another nice color, and it says describe the transformation y is equal to cos x would have to undergo to become f of x. So the original graph to get to f of x, and f of x is negative cos x. So it would have been reflected upon the x-axis. Okay, it's been reflected upon the x-axis. Describe the transformation that the original y is equal to cos x had to undergo to become g of x. So g of x, let me just write it here, g of x was cos x minus 1. So can you see the only thing that has been added is a minus 1 at the back? So thus it has been shifted down because it's a minus with 1 unit. Okay, now it asks you for which values of x is f of x bigger than 0. Okay, so f of x, let's just get our graph in, or our eye in. It's the purple graph. Okay, it's the purple graph, and they ask you, where's f of x bigger than 0? So they are in actual fact talking about the y values. Where's the y values? Bigger than 0 means positive. Now the way I always see it is I see this is the ocean. Okay, that's the ocean line. This is everything above the ocean. And everything else in this picture is below the ocean. So that is all below the ocean. Can you see that? So fish are swimming here at the bottom, but where is it bigger than 0? For which values of x is this graph, this purple graph, original purple graph, now it's a bit of blue graph, where is this bigger than 0? So where is it sticking out over the ocean line? Where is it sticking out of the water? So can you see for which values of x? So it would be 90 all the way up to 270. It's this part that's sticking out of the ocean. I hope you can understand it like that. So you're going to say x is an element of round brackets because I don't have that stripey underneath. X is an element of 90 to 270. Let me quickly add another question like this. All right, so let's just look at the inverse of that. For which values of x is f of x smaller than 0? So f of x, again, was this purple graph. Let me just draw it again nicely with black over so that you can all see which one I'm talking about. Okay, so now it asks you for which values of x is it smaller than 0. So what does that mean? It means smaller than, which means under the sea. Under the sea. Where's this graph? Under the sea. Down where it's better. Down where it's wetter. Take it from me. I've got young kids. You can see that. Okay, so can you see it's those two parts? So it's x values is from 0 to 90 and from 270 all the way up to 360. So you are going to say x is an element of 0 to 90 and x is an element of 270 to 360. So there's two parts where it's under the sea, 0 to 90 and from 270 to 360. All right, I hope that makes sense. And then I want us to quickly sketch the following graph, a last question where we just have a vertical stretch and a shifting up and down, and then just questions what I could ask following this. All right, so there's the graph drawn for you, labeled our turning point, and then you will see we don't have that x-intercept. So I just want to show you how we can work out that x-intercept over there. So in grade 11, they will ask you, and this one I think should go a little bit more like this. Let me see if I erase that, then I'm going to erase everything there. Like that. It doesn't look so great, hey? -1. Let's stick to the original. Okay, but in grade 10, I just want to show you, it's more grade 11 work, but I just want to show you how to find this x-intercept over there. All right, so there the graph is drawn. I've labeled my minimum point, and I just want to show you how to work out this x-intercept over there. So how do we find an x-intercept? If you can remember from straight line graphs, how do we find the x-intercept? By making y 0. So remember here, your y value is 0 over there. So for that x-intercept, y 0. So we are going to, let me just recalculate it here for you. We're going to write up the equation, which is f of x is equal to 2 cos x minus 1. So f of x is equal to 2 cos x minus 1. And then we're going to make the y value 0. Then we're going to throw over the -1. We're going to add 1 on both sides. And then we're going to divide by 2 to get rid of that 2 in front of the cos. So then you get cos x is equal to 1/2. So how do we find x? We're going to say shift cos and then 1/2. And then if you do that, you're going to get x is 60 degrees. So we know that that is going to cut through at 60 degrees. So just a little bit of grade 11 work that's to come. And then I want to ask you, so let's quickly look just a few questions, random questions. If we have this equation, so can you see that from the original, let's say from an original, f of x is equal to cos x. Can you see it's been stretched with an amplitude of 2, because from 1 to 2, and then it's been shifted down 1 unit. All right. If I had to say to you, please reflect it upon the x-axis. I don't know if they'll ask you, please reflect upon the x-axis. Okay, so if you reflect upon the x-axis, you are going to make the y negative. So you are going to put a negative in front of the whole f of x. So your whole equation, so that means you're going to have the reflected, let's call it g of x, another graph, just g. So you're going to have that negative in front of the, which one are we reflecting? Let's reflect this one over here. Okay, so if you reflect it upon the x-axis, your whole y must change. So the negative goes in front of your whole equation, which is cos x minus 1. So what will happen with the reflected graph? It will be negative cos x plus 1, because the negative goes to both values over there. All right, so let's just take another one. Let's call it h of x was, let's say 3 cos x plus 4. And I say to you, reflected upon the x-axis, let's call it m of x. So if you reflect it upon the x-axis, the whole equation must get a negative, oopsie, sorry, not negative 3, must get a negative in front, which will make it m of x is equal to negative 3 cos x, and the plus 4 becomes a minus 4. So if you look at that, it will be stretched. I'm just going to draw a rough sketch of it. Plus 4, so if it originally started 1, it will sort of start at 4 over there. So it will, look something like that. Okay, now if you're going to reflect it, it will look something like that. So can you see this value changed from a positive to a negative? So where it's a 4 maybe over there, it is now a negative 4. So that's why the negative has to go to both terms inside the bracket. Okay, I hope that helped. I'm going to make another video after this where it's an exam type question where we throw two graphs onto one set of axes, and then there's lots of questions that go around those two graphs. And if you can do that, you should be well into almost finishing with trig graphs, or well aware of all the types of questions that you can get. And after that, I just want to make one more video on the trig graph, and I'm also going to throw it into with combining it, with the sine or the cosine graph. Okay, grade 10s, you must have a wonderful day. If you're busy with exams at the moment, all the best, and please let me know if you need something or if you want me to do a video on something. I'll always glad to help. Okay, have a great day, grade 10s. Thanks, bye.